Hello and welcome to another video for pre-calculus. This is the second part of solving trigonometric equations. So the first example here, we have 1 minus cosine theta equals 2 sine square theta. So especially when we have two different functions in the same equation, so we have cosine and sine. One thing we looked at such type of examples earlier where we could have factor out one of the ratios and then we could factor that and then solve the equations. But here it's not that case. We cannot factor out anything. So we have cosine and sine. So this is similar to saying that we have two different variables in an equation in an algebraic equation. Okay, so what we have to do here is we have to change sine in terms of cosine or cosine in terms of sine. So I think looking over here, it's easy to change this sine squared theta in terms of cosine using the Pythagorean identity. So we are going to do that. So before we do it, let's move this one to the left hand side, or let's go ahead and subtract 2 sine squared theta from both sides. So let's go ahead and do that. So we have 1 minus cosine theta minus 2 sine squared theta equals 0, and then 1 minus cosine theta minus 2 times. So sine squared theta can be written as 1 minus cosine squared theta equals 0. So we have 1 minus cosine theta minus 2 plus 2 cosine squared theta equals 0. So simplifying this, we get 2 cosine squared theta minus cosine theta minus 1 equals 0. So this is a quadratic equation and we can factor this. So the factors are 2 cosine theta plus 1 times cosine theta minus 1 equals 0. Now from the first one, if we take 2 cosine theta plus 1 equals 0, and then if we solve for cosine theta, we get cosine theta equals negative 1/2. And from the second one, if we solve for cosine theta, we get cosine theta equals 1. So we know that cosine theta is negative 1/2 at 2 pi over 3 and 4 pi over 3. So which means from the first one, we get theta equals 2 pi over 3 and then 4 pi over 3. And then we know that cosine theta is 1 at 0. So from the second part, we get theta equals 0. Okay, so this is the solution in the interval. So this is the solution in the interval 0 to 2 pi. Now let's go ahead and write all solutions. So all solutions, we just add 2 pi n. So 2 pi over 3 plus 2 pi n, where n is an integer. That's for this one. And then the next one is 4 pi over 3 plus 2 pi n. And the third one is theta equals 0 plus 2 pi n, which we can just write 2 pi n. So this represent all solution for that equation. Let's look at another question here. So in this question, we have sine 2 theta. So we have this double angle here plus cosine theta equals 0. So let's go ahead and use the double angle identity here. So this one becomes sine 2 theta can be written as 2 sine theta cosine theta plus cosine theta equals 0. Here we do have sine and cosine, two different functions here, but we can factor that out. So it's not a problem here. We don't have to change this in terms of sine only or cosine only because we can factor out cosine theta. So let's go ahead and do that. So cosine theta factored out gives us 2 sine theta plus 1 equals 0. Now from here, cosine theta equals 0. And then from the second one, we get sine theta equals negative 1/2 because we subtract 1 and then we divide by 2. So now we know that cosine theta is 0 at pi over 2 and at 3 pi over 2. So from the first one, we get theta equals pi over 2 and then 3 pi over 2. Now from the second one, we have sine theta equals negative 1 half. So sine theta is negative in third and fourth quadrant. So sine theta is negative 1 half at 7 pi over 6. So right here. And then at 11 pi over 6, which is right here. So we get theta equals 7 pi over 6 and then 11 pi over 6. So these are the solutions in the interval 0 to 2 pi. So this is the solution in the interval 0 to 2 pi. Now let's go ahead and write all solutions. All solutions. So theta equals, so for the first one, so let's look over here. Okay, so we have pi over 2 and then we have 3 pi over 2. So we can combine these two actually. We can write pi over 2 plus pi n, which means if we take n equals 0, we get pi over 2. If we take n equals 1, we get pi over 2 plus pi, which is 3 pi over 2. And then if we get n equals 2, then that adding another pi would take us here, and then adding pi will take us here. So it just keeps bouncing between these two values. That's what we want. So instead of writing pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n, we can just write pi over 2 plus pi n, where n is an integer. And then for 7 pi over 6, we write 7 pi over 6 plus 2 pi n, and then theta equals 11 pi over 6 plus 2 pi n, where n is an integer. So this is the solution, all solutions for this equation. Let's look at another example. Here, this is similar to the previous one. So we're going to use the double angle formula here. So remember, for cosine 2 theta, we have three different formulas. So one is cosine square theta minus sine square theta. The other one is 2 cosine square theta minus 1. And the other one is 1 minus 2 sine square theta. So we need to be careful here which one to use. We have sine theta here. So it's better to change this one just in terms of sine. So we are going to use that third one, third identity for cosine 2 theta. Okay, so we will write cosine 2 theta is 1 minus 2 sine square theta equals 3 sine theta minus 1. So let's take this one on the other side because we have this negative here for sine squared. So let's make it positive. Okay, so let's take everything on the other side. So that gives us 2 sine square theta plus 3 sine theta. And then when we subtract 1, so we get minus 2 equals 0. Again, this is a quadratic equation, so we can factor this. So the factors are sine theta plus 2 and then 2 sine theta minus 1 equals 0. Now from the first one, we get sine theta equals negative 2, and from the second one, we get sine theta equals 1 half. So we know that sine theta cannot be negative 2, so which means this is impossible. So this one is impossible. We have to ignore that. Now we'll just take this second one where we have sine theta equals 1 half, which means theta equals, so sine theta is 1 half at 30 degrees or pi over 6, and then at 150 degrees or 5 pi over 6. So theta equals pi over 6 and 5 pi over 6. So this is the solution. Okay, so this is the solution in the interval 0 to 2 pi. Now we'll write all solutions. So all solutions can be written as theta equals pi over 6 plus 2 pi n, and theta equals 5 pi over 6 plus 2 pi n, where n is an integer. Let's look at another example here. So this is a little bit different because there's no identity that we can use here, and then we have sine theta and cosine theta. So it looks like we have two variables we cannot factor out, we cannot use any identities here. So how do we do this type of problem? So the thing that we are going to use here is we are going to square on both sides. That way we'll be able to use the identities. Okay, once we get this square, then we can use the Pythagorean identities. So what I'm going to do is I'm going to square these on both sides. So when we do that, this is what we are going to get. So we have sine theta minus 1 is square means, so if you multiply sine theta minus 1 by itself, you're going to get sine squared theta minus 2 sine theta plus 1. And then if we bring that cosine square theta on the left hand side, so we get minus cosine square theta equals 0. Or this is sine square theta minus 2 sine theta plus 1. So I'm going to change that cosine square theta in terms of sine so that we have only sine in the equation. Okay, so minus, so I'll write 1 minus sine square theta equals 0. So which means we have sine square theta minus 2 sine theta plus 1 minus 1 plus sine square theta equals 0. And if we combine like terms, so we have 1 minus 1, that is 0, and we have sine square theta plus sine square theta, so we get 2 sine squared theta minus 2 sine theta equals 0. Now we can factor out 2 sine theta, and we get sine theta minus 1 equals 0. So from the first one, if we do 2 sine theta equals 0, we just get sine theta equals 0. And from the second one, we get sine theta equals 1. So from the first one, sine theta is 0 if theta is 0 or 180, or we can say pi, okay? And then sine theta is 1 if theta is pi over 2. So yeah, that's the only case when theta is pi over 2. Now, one thing that's very important is if we square on both sides, so in this case, what we have to do is we have to check our solutions, okay? So we always have to do because we squared on both sides. So why we need to do that? Because when we square on both sides, the negative, even if we have a negative that is a square and we make it positive, so basically a negative value, we just change that to positive because we square that. So because of that, we have to check our solution here. We might get some extraneous solution. That means we get the solution, but that does not work for the equation. So what we do here is we'll take these values or these solutions, and we'll check them in the original equation. So we have the original equation sine theta minus 1 equals cosine theta. So if I take 0 and plug it in here, I get 0, sine 0 is 0, so I get negative 1 equals cosine 0 is 1. So negative 1 equals 1, that is not true, which means 0 is not the solution. When I take pi, okay, so if I take pi and put it into the original equation, so what happens if we put pi here? So sine pi is 0 minus 1 equals cosine pi is negative 1. So this is negative 1 equals negative 1. That means pi works. And if we take pi over 2, so sine pi over 2 is 1 minus 1, and cosine pi over 2 is 0. So we get 0 equals 0, which means pi over 2 also works. So our solution in the interval 0 to 2 pi, so in that interval, the solutions are pi and, sorry, pi over 2 and pi. Let's put them in order, sorry. So this is pi over 2 and then pi. Now, all solutions are theta equals pi over 2 plus 2 pi n and pi plus 2 pi n, where n is an integer. So always make sure that if we square, we have to check our solutions. So let's look at this another example. So these are the examples where we have multiple angles. So we have cosine 3 theta, and then we really don't use identities here. What we do is we solve this a little bit differently, okay? So let's go ahead and solve this as we used to do the other one. So what we do is we add 1 on both sides. So we get 2 cosine 3 theta equals 1. So if we divide by 2, we get cosine 3 theta equals 1. Okay, so this is multiple angle. So we'll find the value for 3 theta first. And then after that, we'll find the value for the theta. Okay, so we know that cosine is 1 at pi over 2. So cosine is 1 at, sorry, this is 1/2. Why do I have 1? So this is 1/2 when we divide by 2. So cosine is 1/2 at pi over 3 right here, and then add 5 pi over 3. So cosine is positive in the third, sorry, fourth quadrant. So it is right here. It's 1/2 at 5 pi over 3. So this means 3 theta equals pi over 3 and then 5 pi over 3. Okay, so usually when we have this multiple angle, in these cases, what is very useful or what is very easy to do is first we'll find all solutions and then we will find the solution in the given interval. So that way it's very easy to find those values. Okay, so now let's go ahead and write all solutions for 3 theta. So we are not going to find theta yet. Okay, first we'll write all solutions and then we'll find the theta. So from here we are going to write 3 theta equals pi over 3 plus 2 pi n. So for the first one, and for the second one, 5 pi over 3 plus 2 pi n. Now we are supposed to find the value of theta, not 3 theta. So in order to find theta, what we do is we divide everything by 3. So divide this one by 3, this one by 3, and this one by 3. So that way we get theta equals, so pi over 3 divided by 3 is pi over 9, okay, plus 2 pi n over 3. Similarly, 5 pi over 3 divided by 3 is 5 pi over 9 plus 2 pi n over 3. Okay, so this one is the all solution or the general solution. So this is all solutions for this equation. Now let's go ahead and find the solution in the interval 0 to 2 pi. So what we do here to find the solution in the interval 0 to 2 pi, we'll just take n equals 0, 1, 2 and check whatever value works in that interval, okay, or whatever values are in that interval. So theta equals, so if I take n equals 0 for this first one, if I take n equals 0, so this second, this term becomes 0, so I just have pi over 9. And then if I take n equals 0 here, I get 5 pi over 9. Then if I take n equals 1 here, I get pi over 9 plus 2 pi over 3, okay, which gives us 7 pi over 9. And then if I take n equals 1 here, and in the second one, if I take 1, so I get 5 pi over 9 plus 2 pi over 3, which is 11 pi over 9. Still, this is less than 2 pi, okay? So once we cross 2 pi, then we have to stop. Or once we get the value that is greater than 2 pi, we have to stop. So still, this is not greater than 2 pi, so we keep going on. So the next one is we'll put n equals 2 here, okay? So when we do n equals 2, so we get pi over 9 plus 4 pi over 3, and that gives us, so 13 pi over 9. So this is 13 pi over 9. So let's go ahead and take n equals 2 in the second one. So when we take n equals 2, we get 5 pi over 9 plus 4 pi over 3, that becomes 17 pi over 9. Still, this is not greater than 2 pi. Okay, now let's see if we can take n equals 3. So if we take n equals 3, we get, for the first one, we get pi over 9 plus 3 times 2, 6 pi over 3. This is greater than 2 pi because when we add this, we get 19 pi over, so 6 times 3, 18, 19 pi over 9, which is greater than 2 pi because when we divide by 9, we get greater than 2 pi here. So that means this is not possible. And we get the same thing with the second one. So that means our solution in the interval 0 to 2 pi are these values. Let's look at another one. Here we have the half angle, and the process of doing is and this one is exactly like the one that we did in the previous example. Okay, so let's go ahead and add 1 on both sides. So we get 2 cosine theta over 2 equals 1. And then when we divide by 2, we get cosine theta over 2 equals 1 half. So we know that cosine is 1 half at pi over 3 and 5 pi over 3. Okay, so which means we get theta over 2 equals pi over 3 and then 5 pi over 3. So let's go ahead and write the all solutions. So theta over 2 equals pi over 3 plus 2 pi n and then 5 pi over 3 plus 2 pi n. But we are trying to find theta, not theta over 2, so we multiply everything by theta. Sorry, everything by 2. So when we multiply by 2, so we multiply everything by 2, so that becomes theta equals, so when we multiply by 2, we get 2 pi over 3 plus 4 pi n, and then we get 10 pi over 3 plus 4 pi n. So now this is the solution, which is the general solution or the solution, all solutions. So this is all solutions. Now let's go ahead and find the solution in the interval 0 to 2 pi. So in 0 to 2 pi, to find the solution, what we do is first we'll put n equals 0. So when we put n equals 0, we get 2 pi over 3. So this is still less than 2 pi, so we take that solution. In the second one, if we put n equals 0, we get 10 pi over 3, which is greater than 2 pi, so we cannot take that. So we don't get any solutions from the second one in the interval 0 to 2 pi. So these values are more than that, okay, more than 2 pi. Now here in the first one, when you put 0, we get that one. If you put 1, we get 2 pi over 3 plus 4 pi. See, this 4 pi is already greater than 2 pi, and we are adding something, so the whole thing is already obviously greater than 2 pi. So we cannot have any other value. So this is the only value that we have in the interval 0 to 2 pi. Let's look at one more example. So here we have multiple angles and we have two multiple angles. So this is a little bit different than what we were just doing. So we have 2 theta and 4 theta. Okay, so let's bring that cosine 4 theta to the left hand side first. So we have sine 2 theta minus cosine 4 theta equals 0. Now here we have 2 theta and 4 theta. We know that we have a formula for 2 theta, but we don't have a double angle formula for 4 theta. So we just have to use a small trick here. Okay, so what I'm going to do here is I'm going to let x equals 2 theta. So when I do that, I can rewrite this equation as sine. So in place of 2 theta, I can put sine x minus cosine 4 theta means it is 2 times 2 theta or 2 times x, or I can write cosine 2x equals 0. Now when I do that, now I just have sine x and cosine 2x. That means I can use the double angle identity for cosine 2x and change that in terms of sine. So I can rewrite this as sine x minus 1 minus sine is, sorry, 1 minus 2 sine squared x equals 0, because cosine 2x is 1 minus 2 sine squared x. And then we have sine x minus 1 plus 2 sine squared x equals 0. Let's put them in order. So 2 sine squared x plus sine x minus 1 equals 0. Again, this is a quadratic equation, so which means we can go ahead and factor this. So the factors are sine x plus 1 times 2 sine x minus 1 equals 0. So from the first one, we get sine x equals -1, and from the second one, we get sine x equals 1/2. So which means we get x equals, so sine is -1 at 3 pi over 2, so right here. This is where we have -1. So this is 3 pi over 2. And then sine x is 1/2 at pi over 6 and 5 pi over 6. So we can say from the second one, x equals pi over 6 and 5 pi over 6. Now we are not done. We found the value of x, but actually we want to find the value of theta, not x. So now we know that x equals 2 theta. So this is same as saying 2 theta equals 3 pi over 2 pi over 6 and 5 pi over 6. So now we can say that we can write the general solution in terms of 2 theta. So 2 theta equals, we can write 3 pi over 2 plus 2 pi n, and then pi over 6 plus 2 pi n, and then 5 pi over 6 plus 2 pi n. So now if we divide by theta, then if we divide by 2, we get theta equals 3 pi over 4 plus pi n. So the first one. And the second one, we get theta equals pi over 12. Okay, so pi over 12 um, plus, sorry, this is, yeah, 3 pi over 4 plus pi n, then pi over 12 plus pi n. And the third one we get, so we have 5 pi over 6, so that becomes 5 pi over 12 plus pi n. So these are all solutions. Now to find the solution in the interval 0 to 2 pi, what we are going to do is we'll put n equals 0, 1, 2 and see what we get. So for the smallest angle, which is this is the smallest one, so we'll start with that one. So if we take n equals 0, we get pi over 12. And for next one, if we take for example, for this one, 3 pi over 4, so if we take n equals 0, we get 3 pi over 4. And then for this one, if we take n equals 0, we get 5 pi over 12. Okay. Now, for this one, if we take n equals 1, so we get pi over 12 plus pi, which gives us 13 pi over 12. Okay. And then for the top one, okay, so we have 3 pi over 4 plus if we take n equals 1, we get pi. So this gives us 7 pi over 4. And for the bottom one, if we take n equals 1, so we get 5 pi over 12 plus pi, which is 17 pi over 12. Now, when we take n equals 2, if we take n equals 2, this is 2 pi plus 3 pi over 4, which is already greater than 2 pi. Same thing here. When you take n equals 2, we get 2 pi plus something, which is greater than 2 pi. And same thing here. So we cannot take more than that. Okay. So our solutions are just this one. So pi over 12, 3 pi over 4, 5 pi over 12, 13 pi over 12, 7 pi over 4, and then 17 pi over 12. So these are the solutions in the interval 0 to 2 pi. We'll just do this much for this video. I'll see you again in the next video.